For this section of the material, we're going to be dealing with triangles, but we're not going to be dealing with vectors. So that means we're going to be converting angles between various things. We're going to be finding the trigonometric functions of an angle. We're going to be finding the acute angle that has a given trigonometric function. We're going to be finding the missing sides and angles of a right triangle. We're going to be solving practical problems using the right triangle, but we're not going to be doing anything with vectors. An angle can be formed by a rotation. If we start here and we rotate in a counterclockwise direction here, this angle that we've got is referred to as a positive angle. However, if we start here and we rotate in a clockwise direction, this is known as a negative angle. The unit degree is a unit of angular measurement equal to 1/360th of a revolution. A complete revolution to form this red circle here is 360 degrees. A minute, shown as a single quote here, is 1/60th of a degree. A second, shown by a double quote, is 1/60th of a minute, or 1/3600th of a degree. Since the world is basically a sphere, we can use GPS, or Global Positioning System Coordinates, to locate various things on the Earth and provide navigation for various things like cars, planes, and so forth. So if we take a look at Seneca College, it has a latitude of 43.795790 degrees and a longitude of -79.348990. Now if we focus on the latitude, we can see that this has 43 degrees here as part of it, and this also has 43 degrees. So these are common for whether we express it in minutes and seconds, or we just express it as a decimal value in terms of degrees. So this 43 degrees is the same as this 43 degrees here. But if we want to convert from this, which is a decimal degree, into minutes and seconds, what we have to do is take this part here, the 795,790, and divide it by 1 million. And because that's what this is a fraction. And we say this to 1 million is what is x to 60, and we can work out that to get x converted to minutes, we're going to have to multiply 60 by 795,790 over a million, and what we get is 47 and a fractional part here. And this 47 here is our minutes that we can see up here. Now what we're left with is this part here, set point 7474. Now if we multiply that by 60 and put that over 10,000, what we're going to get is 44.844 minutes. And that's exactly what we had originally. So that means that 43.795790 degrees, when expressed in minutes and seconds, is 43 degrees, 47 minutes, and 44.844 seconds. And that is exactly what we see here. To go back the other way, we take our 43 degrees, put 47 over 60, and put 44.844 over 3600, and when we do the math, we come up with 43.975790 as we have here. The vertex of a circle is the center point of a circle, and if we draw an angle starting from the vertex up, that forms an arc. And if the arc length here is exactly the same length as the radius, so the number of degrees is called 1 radian. Now the circumference of a circle, which is the entire outer part of the circle, is equal to 2 pi times the radius. And that also means 2 pi times the radius is 360 degrees, because 360 degrees is one complete rotation. So if we want, we can write this as radius is equal to 360 over 2 pi, as you can see here, and that's known as 1 radian. 1 radian is equal to 360 degrees over 2 pi, which is approximately 57.3 degrees. If the black arrow is rotated one complete revolution in the red circle, it forms 360 degrees, or 2 pi radians. Each degree can be further broken into 60 minutes, and each minute can be further broken into 60 seconds. Because 360 degrees is equal to 2 pi radians, we can solve this question of converting 47.6 degrees to radians and revolutions. So let's take a look at doing it to radians first. So 47.6 degrees times 2 pi radians divided by 360 degrees, the degrees go out. When we do the calculation, we get 0.831 radians. And since there's one revolution per 360 degrees, then 47.6 degrees times 1 revolution per 360 degrees. Again, the degrees cancel out, and we're left with 0.132 of a revolution. If we want to now convert radians to degrees, we're going to take the radians that we have and multiply by 360 degrees over 2 pi radians, and you can see the radians cancel out. When we do the math, we get 105.84 degrees. And we also know that 1 revolution is 2 pi radians, so if we multiply that by the number of radians, again the radians go out, and we're left with 0.29401 revolutions. If we want to convert 1.0000 radians to degrees, again we multiply by 360 over 2 pi radians, and we cancel out the radians. We get 57.296 degrees. So 1 radian is 57.296 degrees approximately. Also, since 1 minute is 1/60th of a degree, 1 minute is 0.02 degrees approximately. 1 second is 1/3600th of a degree, so that becomes 1 second is 0.0003 degrees. Now let's convert 28 degrees, 17 minutes, 37 seconds to degrees in radians. Like we did before with the GPS, it's 28 plus 17 over 60 plus 37 over 3600. And what that means is we're just going to add these numbers together, and we're going to end up with 28.2936 degrees. Then to convert that to radians, we just multiply the degrees by 2 pi radians per 360 degrees. The degrees go out, and we're left with 0.493816 radians. Let's convert 1.837520 radians to degrees, minutes, and seconds. First thing we have to do is take that number of radians and multiply it by 360 over 2 pi radians to get 105.2821 degrees. Now we're going to leave the degrees alone and just take a look at the fractional part here, because as we know, a minute is a fraction of a degree. So 0.2821 degrees times 60 minutes per degree gives us 16.93 minutes. So out of this, we're just going to keep 16 as the actual minutes. We're going to take the 0.93 and we're going to multiply it by 60 seconds per 1 minute, and we get 56 seconds. So our 1.837520 radians becomes 105 degrees, 16 minutes, 56 seconds. Let's take a look at a triangle here, and we're going to use the origin here as being the 0, point of an x, y axis. Now the initial side here of our triangle will be along the x-axis, and the terminal side here is called the hypotenuse up here, and that will be determined by this angle here. And this angle here is usually referred to as theta, which is a Greek symbol. Now for this angle, which is here, this is our opposite side here, this is our adjacent side here, and the longer side is always known as the hypotenuse. Now there are trigonometric functions, sine, cosine, tangent, cotangent, secant, and cosecant, that are basically ratios of the various sides of our triangle. Now if we take a look here, x is our adjacent and y is our opposite, and r is our hypotenuse. So it can be expressed in a couple of different ways. So for example, the sine of theta, which is sin of theta, can be expressed as opposite over hypotenuse, or y over r. The cosine of theta can be expressed as adjacent over hypotenuse, or x over r. The tangent of theta can be represented as opposite over adjacent, or y over x. And the cotangent is the opposite of tangent. Secant is opposite of cosine, and cosecant is opposite of sine. And these are your basic 6 trigonometric functions that are ratios of one side over another side. As we saw from the chart, tangent and cotangent are reciprocals of each other. So if we're asked to find the tan of theta, if we know cotan is 0.638, then since tan theta is 1 over cotan, then we can just say 1 over 0.638, and therefore we know the tangent of theta is 1.57. If you're given a triangle, such as one side is 4.37, the other side is 2.83, and it has a right angle here, or 90-degree angle, then the sine of theta here is going to be opposite which is the y value over the radius here, or hypotenuse. And what you're going to find is that the radius squared is x squared plus y squared. So to find the radius itself, it's the square root of x squared plus y squared. And you work it out with these numbers, you're going to find that the hypotenuse, or r, is 5.21. Cosine is adjacent over a hypotenuse, which is going to give us this value. The tangent is this value. And as we saw before, the sine is going to give us 0.543. Now, the tangent and cotangent are reciprocals, so that's why you get 1.54. The cosine and the secant are opposites, so 4.839 becomes 1.19. And finally, the cosecant, which is the reciprocal of the sine, 0.543 reciprocal will give us this. And you should be able to validate that these are indeed correct answers for these sine, cos, tan, cotangent, secant, and cosecant ratios by doing these calculations yourself. Now, sometimes you might be given coordinates like x equals 8.84 and y equals 3.15 and asked to find the sine, cos, and tan of an angle, and it could be either theta or b or any kind of angle that you want to put in here. So the first thing you have to do is draw things so you can see that this is 8.84 here. That's where it comes to on this part here. The line 3.15 when you move it over is here, and it does form a right angle triangle. So our opposite side here is 3.15 and our adjacent side here is 8.84. Now we do have to work out what the hypotenuse is, which is r here, and we find that that's 9.38. So the sine of b is going to be y, which is our 3.15 over 9.38, and that gives us this value here. Our cosine is going to be our x value, which is 8.84 over that, which is going to give us this value here. And the tan is the opposite over adjacent, which is 3.15 over 8.84, and that gives us our value here. Sometimes you're asked to evaluate expressions that have numbers like 7.82 minus 3.5 times cos of 67.8 degrees. What you have to do is work out what is the cosine of 68 degrees and plug it in here. And then because our numbers here had 3 significant digits, you should write the final answer to 3 significant digits. Sometimes you're given an expression like this, 1.836 times sine of 2 plus 2.624 times tan of 3. Since there's no degree symbol given, we're going to assume that these angles are in radians. When we do this, we're going to get 1.836 times the sine of 2 radians, which is 0.90930, plus 2.64 times the tan of 3 radians, which is minus 0.14255. And again, when we take a look at our numbers, these are all 4 significant digits, so we're going to make sure our final answer is also in 4 significant digits.
Let's see how we would go about finding the sine, cos, tangent, cosecant, secant, and cotangent of 30 degrees. First thing we do is we put in 30 degrees and we hit sine. The sine of 30 degrees is 0.5. If we do 1 over this, this is the cosecant of 30 degrees, which is 2. Now if we do 1 over and do second inverse sine, we get our 30 degrees back. At this point we want to find out the cosine of 30. Cosine of 30 is 0.866, and the secant of 30 is 1.155. Again, we can hit 1 over and do the inverse cosine to get our 30 back. If we want to find the tan of 30, the tan of 30 is 0.557. The cotangent of 30 is 1.732. And again, we can hit 1 over x and do the inverse tan to get back our 30.
Here we've summarized the results for the degree 30. Sine is 0.5, cosecant is 1 over that, which is 2, cosine is 0.866, secant is 1 over that, which is 1.155, tangent is 0.5774, and cotangent is 1 over that, which is 1.732.